everyone. We are Group 9 from Section 6, and my name is Mutalib, and today we're gonna present our Project 2 of Probability and Statistical Data Analysis, and our topic is Statistical Analysis on Students' Social Media Addiction. And so let's start. And so for introduction, social media, as we know, these days are getting very addictive in both high school students, students in the universities, even students who are doing masters or doctors. So social media became deeply embedded in students' life. Like some people use it very long time, like 5 hours, 6 hours a day, just doom scrolling and doing nothing. So in our project, we are investigating how social media usage affects addiction, mental health, sleep, and academic level of the students. We used inferential statistics to analyze the relationship between three factors. And so for this, there was 705 students from multiple academic levels from different countries, which the data we got from Kaggle. So now we talk about the data. So about the data, the source was Kaggle, and it was called Student Social Media Addiction, which we put the link for this data in our report already. You can check it there. And so variables we used for this analysis were gender of the students, academic level, average daily usage of social media, sleep hours per night, mental health scores, and addicted scores, which is the score from 1 to 10. So we cleaned the data to remove any missing values. Then we formatted all the columns so we can analyze the data with our program, with our studio. So we did 4 type of tests, and for all of the tests, we used our studio to do the test. So now I'm going to talk about the first test we did. So the first test was 2-sample t-test, and the goal for this test was compare average addicted score between male and female students. And so first we talk about the hypothesis we made. So zero hypothesis is when mean of male students equals to mean of female students, and hypothesis 1 is mean of male students is not equal to mean of female students. So after calculating it, as you can see, we grouped it here, and mean for male students and mean for female students are 6.36 and 6.52, and the variance is 2.10 and 2.93, and the sample size for male is 352 people, and for female it's 353. And as a result, after doing the test and the analysis, so the t statistics were negative 1.319, and p-value was 0.1875. And the conclusion from this test is no statistically significant difference. So gender does not affect addicted score. Like it doesn't matter if they are male or female. The addiction score doesn't change. Doesn't change if you are male or female. So now my friends gonna talk about 3 other tests that we did. So Hamza, you're up.
Hello, my name is Hamza, and I'm gonna talk about the correlation testing. We conducted a Pearson correlation test to examine the relationship between average daily social media usage and mental health scores. The significant level was set at 0.05. In the hypothesis number one, 0, I mean, the null hypothesis, no correlation between the average daily use and the mental health score. But in hypothesis number one, there is a significant correlation between the two. After you do the calculations and the formula for the Pearson correlation coefficient, you can get the results as the correlation coefficient equals to negative 0.8, and the p-value 7.85, and the confidence interval equal to on the graph negative 0.8 negative 0.8 on the x-axis and negative 0.7 on the y-axis. As you can see on the screen right now, the it's the scatter plot version of the table shows the daily usage of average daily usage and the mental health score. In the end, the conclusion of this test, there is a strong negative linear correlation between the average daily social media usage and mental health score. This suggests that the students who spend more time on social media tend to have more lower mental health score, indicating potential psychological impacts of excessive usage. That's all for me, and now to my friend Kai.
Okay. Um, Hi, I'm Kai. I will present the regression analysis as part of our project. In this part, we wanted to examine whether social media usage and sleep duration can predict students' social media addiction levels. We use multiple linear regression with dependent variable addictive score and independent variable average daily usage hour and sleep hour per night. And you can see the regression formula here, where y is addictive score and x1 is average daily usage hours. X2 is sleep hours per night. Then here is the result we got. And additionally, the R squared value is 0.723, which means the model explains 72.3% of the variance in addictive score. The F static is 915.3 with a p-value less than 0.0001, indicating that the model is statistically significant. The positive coefficient of 0.765 for average daily usage hours means for every additional hour a student spends on social media per day, their active score increased by around 0.77 points. The negative coefficient of negative 0.42 for sleep hour means for each additional hour of sleep, the activity score decreases by around 0.4 points. This means higher social media usage increase addiction levels, while more sleep reduce addiction levels among students. We also create scattered plots with regression lines, addictive score versus average daily usage hours showing a clear positive relationship, and the active score versus sleep hour per night showing a clear negative relationship. This visualization help us see the pattern clearly and support the numerical results from the regression analysis. Overall, this means students who spend more time on social media are more likely to have higher addiction levels, while those who get more sleep are less likely to be addicted. This is consistent with what we expected and help us understand how usage and lifestyle factors relate to social media addiction in a straightforward way. And that's my part. We move to the next one.
So I Kai Loon, and I will do the test for ANOVA. So we have conducted a one-way ANOVA to test whether academic level, which we can see at the first image, got high school, undergraduate, and graduate, has statistically significant effects on students' addicted score. So for the null hypothesis will be all academic levels have equal mean for addicted score. So for the alternative hypothesis will be at least one academic level differs significantly. So we can see the difference in first image, and for the second image will be all the results, which has the sum, mean, and also the F value. The F statistic we can see is 17.11, 17.11, and the P value will be 5.53 times 10 for the power of negative 8, which is smaller than 0.0001. So since the p-value is less than 0.05, so we reject the null hypothesis. So for the conclusion, so there is sufficient evidence to conclude that academic level differs and affects academic EdTech score. Further post analysis could identify which specific levels differ. So next page, for the conclusion, so we can see that for gender, the variable gender has no significant effects, and for the usage, if it's increase, the addiction score will also increase, and for the sleep, if the sleep increase, the addiction will decrease. As for the academic level, will have a significant effects for the predicted score. So what we learned through this project, we know how to use R for hypothesis testing, RStudio, and visualizing data with scatter plots, and also interpreting statistical results for real-world meaning. So I think that's all for the presentation. Thank you.
Thank you.
Thank you.